Welcome back to Coding Along. You are watching the part 3. Yes, we finally reached part 3 of the data structure and algorithm course. And we are going to talk about recursion. And recursion is a very interesting topic. It's something you're going to see on and on when dealing with data structures and algorithm. So I will say for sure, pay attention because this is something that you really need to understand if you want to be good at data structures and algorithms, if you want to be good at problem solving. So yeah, if you're new here, my name is Sam and we do programming tutorials, web development, we do different programming stuff, just things that will make you a better programmer. And this for sure is one of them. So yeah, give it a like, subscribe to the channel, comment if you have any questions below. Let's get to it. What should you expect watching this episode? Because I think that's very important. You need to have some expectation if you're going to devote your time on this. It's a big thing to know at least what you want, what you're going to get from this. So one thing is you're going to understand recursion. You're going to know what recursion is, why recursion is so important, why we use recursion, and how to use recursion. So this is a full-on tutorial where we're not going to deal with only one part. We're going to cover recursion as a topic so that when we go further into this data structure and algorithm, and when we start solving problems and when we start dealing with more complex algorithms and more complex data structures, we can use recursion to help us out because, as I said earlier, recursion is something you're going to meet on and on. It's something you're going to encounter, and it's going to make your programming and problem solving easier. The data structure that powers recursion. Very interesting. We're going to also talk about types of recursion because there are different ways of using recursion. We're going to talk about that, and that's very, very interesting and very insightful when you see the different ways of using recursion. How to think recursively because a lot of people understand recursion on a very basic level, but they can't think recursively. They don't know how to solve problems using recursion. Even if they have an idea, they don't, it's a little bit blurry. It's not something they really understand or know very well. So we're going to delve into this. And before we continue, this is going to be a part 2 or 3 parts video. So keep your heads up for that. This is the first part because I don't want the video too long and I want it to be in short forms where you digest the first video. Then when the second video gets uploaded, you get the second one and the third one. So yes, I just wanted to put that out. And also, one thing you're going to get after finishing and watching and focusing on this video is you're going to be more confident and there's going to be clarity to solve problems using recursion. What is recursion? Well, recursion is something that repeats itself. That is the very broad. If you check the dictionary, you check Google, you write what is recursion, you probably see recursion is something that repeats itself. In programming, you have a function, and I hope you understand what a function is. This is what recursion is about. It's about a function calling itself inside its own code. You can see it here. It's literally keeps on calling, calls it, and then it goes back, it gets called again, goes back, gets called again. So we can see some similarities here with a loop. So what is recursion in terms of programming? Here we have a for loop, and this is going to help us understand it here. And we can see here, when we console.log I, we get 0 to 10. And then when it reaches 10, it breaks because I becomes equal to 10. So we can see there's a similarity between recursion and iteration in the sense that there's a form of repetition. And when I'm using an iterative, that means for loop or while loop, I am doing some repetition. And when I'm using recursion, I am repeating it, especially when, as we saw earlier, you call the function inside the code of that function. Recursion is an alternate way of solving a problem which can be solved by a for loop. It solves it more efficiently and more intuitively. More efficiently and more intuitively. that is why I said earlier that understanding how to think recursively, understanding recursion will make you a better programmer, make you be able to deal with the algorithms and data structures in a more efficient and more intuitive way. What is recursion in terms of programming? So now let's talk about it in terms of program. We did a very vague and very broad definition of it, but in programming, what is recursion? Recursion is a function that calls itself inside its own code. That is what recursion is, and we saw it earlier with the function and the function call happening inside the body of the function. So recursion is a method of solving a problem. This is another way of thinking about recursion. Recursion is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. And we are going to go about it. We're going to have examples on this. So if you're feeling a little bit vague about it, not understanding it fully, watch the end of this video. Watch, just continue with me and we will understand it fully, because that's the main of this video here, is to make you understand it fully, to make you think recursively, to make you really, when you see a recursive problem or when you see a problem, being able to think, oh, can I solve this with a recursion? Because if I can, it's going to make it more efficient, it's going to make it more intuitive. So now we have a little function here, and this function basically is going to print hello peeps, because we can see that in console.log, and we can see the recursive call here because greetme calls itself inside its own function, and we have the function call that initially happens when the code starts. Is there something wrong with this recursive function? Yeah, the answer is yes. This function will keep on calling itself, and the hello peeps will keep on printing until it gets out of memory. This is what we call an infinite loop. This is a recursive pattern, but this is not the right way to write a recursive code. And now we're going to talk about the right way of writing a recursive code. Now let's talk about the right way of writing a recursive code. A recursive function must have three things to work properly. The first thing is the termination condition. And as the name says, this is what is going to make the function terminate. This is what is going to make the function not be an infinite loop, because that was the problem with the other functions we just talked about. The second thing is the logic. What are we doing? What do we want to do? What do we want to solve? What is the problem asking us to solve? It could be perform some calculation. In the case of the other examples we just touched on, it was printing out something, printing a name, printing I, different, it could be anything. You first check the termination condition. I know we haven't talked about the third one, but this is what I'm stressing this because this is very important, something you have to understand. It is satisfied, then you return out of the function. So that is what stops the infinite loop. If it's not satisfied, then you provide some kind of logic. That means, what do you want to do if this termination condition is not satisfied? And you say, keep on solving this until you get to this certain termination condition, which when you get to this termination condition, I know you should be finished with the logic part. Then the third thing is you call the function recursively and change the input size. So these are the three things you have to put into consideration when writing a recursive function. Example of a recursive function. Here we have a function called greetme. It takes in an input n, as we can see. And we can see the comment section here, we wrote termination condition. Our termination condition here is that if n is less than or equals to 0, we want to return out of this function. The logic part is we want to print hello peeps. The third thing is we call the function recursively and modify. Either you increase or you reduce your function's input. And in this case, we are reducing the function's input. In another case, as far as do your code right and the termination condition is right, you can increase the size. And then we call the function out here and we give it an argument of 10. And we can see it here, it prints hello peeps 10 times. So we have example 2 of a recursive function. We want to print all the elements in an array. I hope you understand what an array is. If you don't, you will see what it is here. We want to print all the elements in an array recursively. We have an array here. We have I, which equals 0. I is basically going to serve as our index here. The function print r takes as its input r, which is our array, and I, which is going to serve as our index, as we discussed earlier. The first thing we do when we're making a recursive function is the termination condition. I know it might sound repetitive, but a lot of people don't get this. The termination condition. So in this case, our termination condition is if I is greater than or equals to the length of this array. And what is the length of this array? The length of this array is 1, 2, 3, 4, 5. So we're basically saying if I is greater than or equals to 5, we want to return out of this function. That is our termination condition. The next thing is the logic. What do we want to do? Why did we create this function? We want to print all the elements in an array. The way we print it is we use console.log r, which is the name of our array, and then we put this bracket here. And if you're used to programming, you should understand that this bracket here basically means the index, and then I is serving as our index. So this is going to start from 0, and we know index starts from 0. So 0 index would be 3, 1 index would be 4, 2 index would be 5, 3 index would be 9, and then 4 index would be 7. So this is the logic part. This is why we created this function. This is what we want the recursive function to do. And then last is we call the function recursively and modify its input. So right now you can see here we're not modifying r, but we are modifying I. We are going to increase I because we want this to shift. We want I to be 0 so we can print out 3. Then we want to increase I to 1 so we can print out 4 because we know that 1 index is 4. So I hope this is very clear, and I'm trying my best to make it as clear as possible so you understand this, because this is the foundation. This is what I thrive on. You have to understand the foundation to even go further. That's the problem with most people who are studying data structures and algorithms, is that before you know they're talking about trees and maps and all this, you don't even know the basics of recursion. You have to understand the basics, and that's why I'm covering it here, because I know that with the basics, if you have a solid foundation, you can literally start going on yourself, studying by yourself, and just get more information by yourself. So every time this function is called recursively, I gets incremented. And we can see that I also is in our termination condition. So there is for sure, this is how we know this function will not become an infinite loop, is because we know I is going to keep on getting increment while this function is being called to the stage where I will be greater than the length of this array. So this is the recursive function. And I hope it's clear. But to make it more clear, to make you understand it better, I want us to do a dry run, just to show how the program works. And this is something that I hope you get used to, because if you're feeling a little bit vague about a function you wrote, or you're not too sure about what the function is going to do, dry run it yourself. And that's the next part. We're going to dry run this function. First time I is equals to 0. The array length is, when we reduce the array length in this case, because we don't want to do it till 5, the array length is 3 here. And we can see the array length is 3 here. So it's I is I greater than or equals to array length, that's false. So that means that this return statement doesn't get activated. And then we go down and we console.log 3 because 3 is the 0th index in this array. So then I gets incremented when we call the function recursively, then it starts all over again. And I is still less than the array length. We go back and we print, we console.log r index 1, which is 4. Then we call it recursively and we increase I. So now I was 0 here, I is 1 here. The second time I is 1, and the third time I is 2. 2 is still less than the array length, which is 3, as we can see here. So we still print the last digit, which is 5, and the last value, which is 5. And then I gets incremented to 3. And when I gets incremented to 3, we check the termination condition again. And in this case, I is equals to the length of the array. So this is true. So we return. So this is another part we have to really understand. How do we return? How does that work? Is it that when the termination condition just gets satisfied, we just return out of the loop? That's what we're going to discuss now. So we can see here that we go from step 1 to step 2. Then we go from step 2 to step 3. And we go from step 3 to step 4. And then we see the return statement. But when we see this return statement, it does not return directly. So we return like this. We go from 4 to 3. And we go from 3 to 2. And then we go from 2 to 1. And when we've gone like this, then we return out of the function. So this is something a lot of people don't understand. So unlike a loop, which is one directional, in the case of recursion, it's a complete loop. And you can see that here with this diagram right here. You first move as we see in the arrow. When the termination condition is satisfied, then we move back to the starting position, and when we have reached the starting position, then we return out of the function. So it only terminates from the point it started. And this is a very powerful concept that a lot of people don't understand. But if you understand it, it will make recursion so easy, it will make recursion so clear, and it will make you understand how to solve problems recursively and also think recursively. Next part is going to be about why recursion is a complete loop. We're going to delve deep into it. So keep your heads up for that. That is going to come out really soon. And if you don't understand it fully, repeat this video. Do some recursion on this video. Repeat the video until you understand it. Put a termination condition of, okay, you will stop watching this video when you actually understand what recursion is and how to think recursively. So I hope you gained from this video. I hope you enjoyed it. I hope you learned from it. If you did, give a thumbs up, subscribe to the channel if you haven't, and yeah, the part 2 is going to be coming very soon. And yeah, peace out.